Okay. I'll try to speak louder. Is it better now?
Yeah, it's better now.
Okay. Yeah. Sorry about
Thank
that.
you. Yeah.
So, Remix basically it's an environment used to write and deploy smart contracts. So it's actually not a type of Solidity. For Solidity, when it comes to types, we're talking about different versions. So we've had various versions of Solidity so far. We've had 0.5, 0.6, 0.7, different basically, a lot of that which will be seen as we are developing. So um, I think the people that were here last time, Mr. Gbenga and Mr. Femi, yeah, we worked on this storage smart contracts the last time that we were here, and we'll be going over that again, but we'll be going into in a more complex way. So, for benefit of people that were not here previously, we'll basically be starting afresh. Um, yeah. So let me just call this storage 2. Now in Solidity, yeah, we have first of all each file for people that have coding experience. Each file always has like an extension and it's .sol. So for people that want to code along, I'll drop the link in the chat box now of the call. So this is Remix. Kindly open it in your browser for deployment. Yeah. So you don't need to download the file offline because there is an offline version, or rather, there is an off-browser version, but there's mostly issues with that when trying to deploy to the test network. So now, when it comes to Solidity, this is a plain file. We're just starting. So most times when we want to start on a Solidity language, a Solidity smart contract starts with licenses. So in this case here, most times we use this license. So this is a free license, a free Solidity license for our code. Our code will compile without the license, but in some cases it brings warning. So this SPTX license identifier basically gives like a free license for whoever wants to write Solidity code, like a smart contract in this case. So let's just so I'll be copying that and then we'll be working with the rest from our head. If you need, let me just know, is anybody coding along? Do you need this license? Let me just drop it in the box, or probably for me to zoom in. Hello, can you hear me, everyone?
Yeah, yes, I can hear you, but I'm not coding. I was waiting for those who are coding to answer.
Okay, yeah. Okay, then
Yeah, I'm
there's
not
no
I'm not because my laptop is not on.
yeah, there's no problem. I'm actually making a recording, so I'll probably send the recording after the call.
Hold on, for those
So
of you who are not coding, yeah, you are going to have an assignment after today's class. So please, we are going to give you 2 days to do the assignment. So by Friday, we would be collecting all the assignments in code, not in text. So you're going to have your in Solidity and then upload it. I think we taught it last week. Did Yola teach it last week? So we want to see your code in GitHub by Friday. Then we take another class to take solutions and then we move you guys to the next stage of your learning. Thank you.
yeah,
Sorry, Mr. Joseph.
yeah,
Mr. Joseph,
yeah.
your screen is going to be from my end or from your end. I want to make it full screen so I can see it clearly.
Okay, so this is I actually like zoomed in so everyone can see the license, but this is my full screen here.
Oh, okay.
So yeah, so probably on the device you can double tap on the mix to make the call bigger, like to make this particular screen bigger.
Oh, okay. Thank you.
Yeah. So after defining the license, note that the license is actually after this double forward slash. So this one here basically means it's commented out, but licensing in codes actually like help. So even in Web2, different applications actually have like different licenses governing them here. So now to our Solidity code. In every Solidity smart contract, we actually start from the first line, and that is defining the Solidity version. So in Remix, if you come here, so under Remix you have different icons on this side. So you have the file explorer, you have the search, and you have the compiler. So here you can see all the versions of Solidity we've had. So we have had so these are just the stable versions. There is then we have like the total list of both stable and unstable. So we had various versions really, but for good measure, we're actually going to be working with the stable version and one of the latest stable versions. So for now, we're picking 0.8.7 as our compiler. So just come here and define that version first. So go pragma solidity and then your version 0.8.7. So that's defines like the Solidity version that we're working with, and that's like the first step you take when writing your smart contract. Then the next thing that we'll be needing is the name of the contract. So how do you initialize a contract? Femi, I think Femi was in the last class. Do you remember how to initialize a contract? Benga, are you there? Okay.
Yes, I am.
No, sir, I can't remember.
Okay. Can you see my screen, everyone, at least?
Yes, so I can see your screen.
Okay. So to initialize a contract, you type in the keyword contract, then you specify the contract that you want. That's the contract name. In this case, is contract storage 2, and then you add in your curly braces. So this one here is basically what we call the framework or the outer shell of your smart contract. So everything you want to define in your smart contract is going to be written between these curly braces. Every single thing you need. So that's how you start with the contract. Now, in Solidity, we have different things. We have different variables. So most the things we'll be working with for this call is basically variables and functions. So Solidity, we have like string variables, we have integer variables, we have different variables. But one of the most important things we have, and that confuses people a lot, is int and uint. So in this case now, we are basically defining an integer. So we have so int in this case means integer, and uint in this case is unsigned integer. So what this basically means is, if let's say we have balance, in this case we have int balance, and then we have uint total balance. So first of all, now we see that we have an error here, and what this actually means is it basically means if we try to compile our code, it won't compile. In Solidity, one of the most basic things you must know is after each line you have to add your semicolon. So if you don't add the semicolon, the next line will bring an error. So immediately after adding the semicolon, the error here moves away, but we have another error here. So we basically have to add semicolon after each line. So in JavaScript, semicolon is not necessary, but for Solidity, semicolon is absolutely necessary. So here now we have uints and we have ints. Now if we want to define each of them here, we'd see like the basic differences. So let me just put a basic function here that will handle the definition of them. So we have an integer named balance. Now if we initialize balance to a value, let's say 5, and we add a semicolon, we see that our code actually works fine. And if we try to compile this, it will compile, and we have this green check mark here that shows okay, your code has compiled successfully. Now, as an integer, for people that did mathematics probably in secondary school or in uni or other levels of education, we know that integers can actually be positive or negative. So now that we have balance as 5, we can actually have balance as -5, and if we try to compile it, it will compile successfully. But for the case of an unsigned integer, it can be an initialize total balance. If we initialize it to, let's say, 19, we save it, it compiles successfully. But what will happen if we add -19? Can anybody guess? The people that were here previously, I think we should have an idea. Hello? Femi, Benga, just tell us.
Sorry, I'm not seeing the screen very well. So,
Yeah,
can
this
you
is my
please tell me
screen.
the question?
Yeah, so I said when you add a symbol, in this case now, we're putting
Can you zoom out
-19.
on your screen? Can you zoom
In
out
this,
on your screen so that the text can get bigger?
yeah.
Exactly.
So in this case now, we
Better.
are having total balance as -19. So I was asking Mr. Benga, because we were in the last class, why do you think we have this error here? Okay. So basically,
Yeah, that's because okay. Can I go on?
yeah, go on.
Okay, that's because it is total balance, and you can't is just like a real time for a kind of a real time credit. You can't be owing, so you can't have minus.
Okay. Yeah. So that's actually true. That's one way to explain it. So uint basically means unsigned integer, as I wrote out here. So what this means is it cannot be signed. Like you can't have a symbol before any integer initialize here. So that means it cannot be on the negative side of integers. So this simple value of uint actually checks is like a security feature implemented in Solidity as well. It also exists in other programming languages that helps check let's say mathematical expressions for things. So if we had like some token now, let's say you had the token Ethereum, you can't have -5 Ethereum. You have to have like a fixed value. Either you don't own it or you own 0. So if you fix total balance as 0, you see that it's fine. If you fix it as 1, it's actually fine. As 2, it's fine. As let's say 500, it's actually still fine. But once you fix it at -1, you see that you have an error. So that is the main difference between int and uint. Now, does anybody have a question about what I just explained before I move on to more explanation?
Okay, please. Sorry, I have a question. I quickly went to my laptop now, and I'm following. I think the only part I'm stuck is line 9. How you got that gas thingy to show the 529? Yeah, the gas symbol
Yes.
and stuff. How did you get it to show?
Yeah. So this is just a remix feature. So I didn't code it out in this case here. So if you
Okay, okay,
like if I cut this out, um, Remix has actually implemented, let's say, a gas estimator. So whenever you write a function in Solidity in this Remix IDE, they basically estimate how much gas it will cost. If I comment this out, you'll see that okay, the gas amount has actually, I think it decreased and then it increased. So that's just a remix feature. It's nothing special that I implemented.
okay, okay. No problem. Thank you.
Yeah. So so the next thing I'll be moving to is actually byte sizes of integers in this case. Let me just see if I can send a link to this in the documentation. Okay. Um, let me just keep explaining this. So here now we have byte sizes. So if you come here and you try to initialize an integer, you see that you have integers of different sizes, rather different integers. So I see int 104, int 12, int 112, int 12 implies int 120 and co. But basically, we'll be using uint to explain, and we have different values of uint. From uint 8, okay, I'm just keep this at 0 for good measure. So we have uint 8, let's have uint 16, should be x, and let's just go straight to uint 64. So they are basically values of they are powers of 2 in this case. So we have uint 8, uint 16, uint 32, 64, uint 128, but I'll just go straight to uint 256 in this case, and y. So now when you initialize a value, like when you just have, okay, let me just add our basic uint. When you initialize a value here as uint, this value defaults as uint 256. So I'll be showing an output to show that. Now when you just default this value here, the largest value of uint you can have is this uint 256. So it will go, let's say uint 512. You see that it does not, it throws up an error because uint 256 is actually the largest symbol you can have, and that's what an undefined, or rather an unspecified uint defaults to. Now the basic differences between this is each of these numbers specify what the upper bound would be, what the maximum limit of that value would be. So for uint 8, you can actually have different values. You can have 1, 2, you can have them 7, you can even have up to 9, 10, like 11. But it goes to the power of 2, it goes to like 2 raised to the power of this value here. So in this case now we have like, so remember this is Google here, 2 to the power of 8 here. So this is the maximum value that it can store 256. But the way Solidity does it is if we write 256 here, it actually throws an error. So it will read up the error here. So one important feature of Remix is it actually helps you to see the error. So it said literal is too large to fit into uint8. So all these numbers basically are, normally we look at them as numbers, but the way blockchains, like the way computers see them, they see them as storage values. So the maximum value that can actually be stored there is 1 minus this particular value. So for uint8 in this case now, the maximum value you can have is 256. Now if we look at, okay, for uint16, it's basically 2 raised to the power of 16. Was that I think that number is quite large, probably 512. Let's just go with that before and now move on. Okay, so it's not even 512. It's actually a very, very large number. So it can store up to numbers from 0 to 65,000. Now with that, you can now imagine, okay, this has a very high upper bound. So if we calculate for uint256, it's actually very, very large. That's why in most cases we just set uint256 as the value of our variable. So if it's an integer value, let's say it's going to be like a coin balance or the total balance of a particular token, or let's say total balance of a contract or available units of something that we are hard coding into the smart contracts. uint256 is like a default value. We are just going to initialize it. But you can't have something like uint512 or uint1000, things like that. So that's just like the basic explanation of that. This part here is like a lot of mathematical jargons. So let me know if you have any questions relating to what I just explained.
No questions from me. Thank you.
Okay. Yeah. So so let's just clear this, and then we'll move on. So now you see I added this constructor function here. So what the constructor does is when you have values that are defined in a smart contract, the constructor functions initializes those values to a particular, so when you have variables given in a smart contract, the constructor function initializes a given value to those variables. So in this case now we have a variable called balance, and we have a variable called total balance. Here now this constructor function assigns a value to that particular balance. So let me show you guys another function here. So apart from constructor functions, every other function in Solidity is initialized with this keyword function. And then let's name this function gets now in a function we have different visibilities. So let me search that up, because I actually have to explain with the documentation for this. So in a function you actually have different visibilities for a particular function. So you will see public. So some functions are actually public. Now these public functions, they can be called by anybody, and they can be called inside the contract. They can be called by maybe a wallet or another contract. So that is the way public functions work. Then you have internal functions. So those functions can only be accessed within that smart contract. So it's like using a function to set a variable and using that variable inside that same smart contract. Now, private functions are basically like internal contracts, but they are not visible to contracts that are based on that contract. So let's leave them private for now. We wouldn't need that. We also have external functions. These external functions means they can be called via a transaction and any method. So, but what we'll be working with mostly in this case now is public. Now, you'll be seeing I'll be adding a few keywords. So we have view. So in this case, we want to get the value of balance and of total balance. So this view keyword here actually specified that okay, we are fetching data from the blockchain. We are not trying to change the blockchain value. So you say public view, normally in other programming languages, we also say return, let's say return balance. You see that it says in this case, you see a different number of arguments in a return statement than a returns declaration. So in this case, what the main cause of this error here is while getting the value from the blockchain, we're actually going to add another keyword here, which is returns. So once we add that, you see that the error goes away. Okay. Sorry. Yeah. So we say public view returns. Now, whatever we're going to return, we actually have to specify it in the Solidity smart contract. So in this case now, we want to return balance. But what is balance? Balance is an integer. So we'll come here and write uint. We get an error. I'm sorry, Mr. Munga, can you mute your mic? Yeah, thank you. So we actually have to specify the type of data that will be returned. So here, balance is an integer. But here we said, okay, we are expecting a uint. So it throws an error that, okay, balance is not a uint. If we come here and let's say, okay, let me change this here to total balance. If we run this here, we see that, okay, it will still run because although we specified it as uint, it is as far as an unstyled integer, it's still within the scope. But let's say we specify okay, yeah, this is the lowest value. Let me just increase this for the test. You see that this one now is uint 16. If we specify this one as uint 8, it will throw an error here. But if we specify it as that value or values greater than that, then it actually allows it to go through. Now, if you just write uint without specifying, it defaults to uint 256. So if over the cursor here, you write uint 256 here, because that is the default value of uint, and it won't throw an error. So here now we are trying to return the balance. So let me just save this and compile. So to compile here, as I explained earlier, when you come on Remix, you see your file explorer, then you see your search, and you see the Solidity compiler. Note when you are testing or going through this on your own, if you don't see any of this, kindly reach out to me on Telegram. There's a way to get it, but basically it's just coming here. You will see a plugin manager here or on the settings. So those are like the basic things that you need. Everything you need is actually already here. You just have to toggle it on. So when you come to the Solidity compiler, this version that we used here, 0.8.7, has to be the same version that you have here. If you choose another version and you try to compile, it takes some time to compile, then throw an error. So that's basically it. So you have to have the same version that you have specified in your code as the same version that you have in your compiler. So let's just compile so I'll be able to show you guys the type of error you have. Yeah, so we have the error, and it says source file requires different compiler version. So you just have to change it back to that particular version that you are using. So once you change it back, you can now compile. So you click here to compile, and it shows the contract. So once you have the green check mark here or here, just know you're good to go. Now, it is a place that we have to take a lot of attention. So, or rather, you have to take a lot of caution, rather. So this here specifies the environment that you want to deploy on. So for test methods, basically, you would actually be working with this Remix VM London. So you see other options, but do not pick any of the other options for now. Just use this Remix virtual. So this VM basically means virtual machine. So that one will provide you with accounts. All these accounts have 100 ether each. That's 100 ETH, basically for deployment and testing purposes. Then you have your gas limits. All these ones have been set on ground. So in, let's say, some higher level smart contracts, you might actually initialize some value here, but we don't need that. So you come here and you pick the contract that you want to deploy. Once you pick it, you click on deploy, and it deploys immediately. So there's actually a terminal here where you can see where the transaction deploys, and you'll see this green check mark, meaning that it's deploying. So on deployed contracts, you see this shows the name of the contract, and then at a random address. So that is where the contract was deployed on this virtual machine. So here now, we said what's the function? What does our get function do? Basically returns the value of total balance. So we click on get. We have a function call here, and what does the call do? It returns the value. So I don't know, should I zoom in? Can you guys see? It returns the value of this, saying what, 255, which is what we specified here. But in this place it's giving you is 256 because that was the type we specified here in this place. So if we change this to unit 16 as was specified in this case, let's delete this and then we deploy again. So we will now have a storage. This is a different version of that contract. So I just updated it, and then if we get the value, we now have the accurate variable type that we specified, unit 16, and what is the value? 255. So that is just a basic explanation of how variable works, how this constructor function works, and then this get function works. So now let me go over this get function again. This function basically returns a value of a given variable. Now a variable was initialized here, rather a variable was defined here, and this constructor initializes the variable. Now let's assume we didn't have anything here. If we delete it and then you save it, you can actually still deploy the contracts and it should work. So give me a minute. Let me compile and deploy. If you deploy it and you get a value, you see unit 16 for the value of the total balance, and it's worth 0 because it was not initialized. But if you come back and like define it and you compile it, you get the value there. So this is basically how the constructor works for the get, you have this public keyword, so you'll be able to access the function. So for other higher level functions, when we proceed to other levels, we'll be seeing the other type of visibility specs you have. This view here, this view basically shows that okay, you're actually getting a value back. So functions, other functions in Solidity are basically changing the state of the blockchain. I will show you a function that changes the state now, but this one basically just gets a value. Then this returns keyword is vital to show the type of value it will be returning in this case. So if you change this one to balance, let's say just normal balance, as I said before, you'll get an error because we have actually specified what it will be returning. So that is that for that. Yeah, let me know if I can proceed. Do we have any questions before I show another type of function?
Okay, look, for me, I had a question initially because when you change the uints from line 14, when you change it to 16, you actually and you did the get function. Mine was still showing something different, but I realized what I failed to do. I forgot to compile first before deploying, but I'm fine now. Thank you.
Okay. Okay, yeah. So let me know, does anyone have any other question for now before we proceed? Okay. So yeah. Next up is a function to change the state of the blockchain. So in that case here, let me just show you. I'm going to show you another smart contract, but that might let me show that for now. So in this case, we want to work with like a function to change this state of the blockchain. So let's just name it change. Now, in this case, we just define public, and that is all we need, or not. We're actually changing the value of, let's change the value of total balance. Total balance should be equal to, let's give it a variable, new value. So here we have an error that says undeclared identifier. So here now, we're actually going to take in a new value. That means we want to be able to set the new value of total balance manually. So we are going to give the option for receiving in a new parameter. So for this function to take a new parameter, it has to be allowed, or it has to be defined, it has to be predefined here. So in this case, it's going to be uint, the same uint 16 that we are using, uint 16, and then we define new value. See that once we add that, the error goes off. If we don't use uint 16, if we just define uint, we actually would have a mismatch error because 256 is not 16. If we go lower than the initial value defined, we should actually take it. But it's best, the whole point of using uint and then specifying a value is for security. So if you are having uint 16 here and then you are using uint 256 and then let's say you are using uint 8 here, even though you will not have a compilation error, you would still it will be like a security risk for you. So it's best to define each value and let all of them correspond to the same byte value. So here now we have uint 16, uint 16 and uint 16. It's just good like that. It doesn't allow for lapses or cases where your contract can be hacked. Now, we have a function here named change, and this change function basically changes the value of a variable on the blockchain. Now we see we don't have this view here and we don't have returns here. That's basically because, first of all, we are not returning a value. So far we are not returning a value, you don't have to specify the return type in this case. And we are not using view here because we're actually not getting any value back, or we're actually not returning any value. We're not trying to view anything from the blockchain. We're just trying to set something on the blockchain. So that's what this function is all about. And very important, you see that everywhere you have your semicolon defined. If I remove it, we'll get an error on the contract. So let's just save this and then compile. Then we come here, we can deploy. So now we see previously we just had a value, we just had a button here that shows get. So basically what this deployed contract interface is like a contract interaction tab where you can interact with your contract here. So you have this get, and now you have a new function called change. So if you get the value, our initial value that we set in this constructor was 255. So but now we want to change that value. So anyone should give me a new value. Like someone should just give me a number that we can use in this case as a new number to set. Hello, anyone there? Let's see, Leo, give me a number,
Take 12.
Okay, 12. So here now, we imputed 12. So 12, we're changing our total balance to 12 in this case. That's what we're trying to do. If we come here and we click change, you see that it logs another transaction here. Now previously our value was 255. If we get the value again, see the value has changed to 12. So that's basically how it works. But now there are changes here. What's the change here? See that this button is blue and this button here is orange. So what it's trying to show is basically every blue button is actually just fetching data from the blockchain, and this orange button here is changing the value on the blockchain. If I wrote a more complex, let's say I wrote a more complex function, you see that this button here will change to reddish kind of, because it's showing how much gas that will cost and how much change is making to a particular variable on the blockchain. Now the main differences here is that this public view returns a function to get data from the blockchain actually does not cost gas. So it's instantaneous. When you see it, when you click on this, like when you click this rather, when you click this, it just shows a call transaction log. If you open it up, you can actually like look at everything that happened here. So it just shows a call log, but if you come here and you change, let's change this to what, 100. If you come here and you change it, it should transact to storage2.change. So that's this function here, change pending. So it will actually take time to run a transaction. If we get this again, we just have a call. So changing data or setting data to variables in the smart contracts on the blockchain would actually cost gas, and it will take time. So the predefined time for a smart contract is actually the predefined time for a smart contract and for a transaction, for an Ethereum transaction, is actually 15 seconds. But depending on scenarios and other things, it actually takes more time than that. In most cases, before each block is confirmed. But getting data from the blockchain is actually supposed to be synchronous. So you're able to fetch the data easier and faster than running the transaction on the blockchain. So this here that we have just written is actually a simple storage smart contract. So we have the integers, we have an unsigned integer type here, and it's initialized in this case to a particular value. Then we can return the value, can return balances and a new value. So let me know, do you guys have any question here?
No, I don't.
Okay. Any other person on the call have any question?
No, not yet for me.
Okay, yeah. So first of all, let me just ask some basic questions here in this case. So can anybody tell me what the first thing to do when writing a smart contract is?
Put the license.
Okay. So after license, what next?
The version of Solidity language.
Okay. So license and then the Solidity version. Okay, so what next? How do you initialize a contract?
Okay, I'm still waiting for the contract developer. I'm a product designer, not solely support. But I think I have to do it together. So these guys are there. Let's not be that
Okay. Yeah, I think I believe their network has actually disconnected. So maybe I'll just make the recording of this available. But as a product designer, there are a few things that would apply to you here, and that is basically when it comes to wait time of transactions, um, fetching data from the blockchain, or sending data. So that 15 to 20 seconds transaction time, there are going to be different things happening on the screen. Probably a widget that shows, or a placeholder that just shows that okay, your transaction is pending and other things. But yeah, I guess that would be when it comes to the design parts of the program. Then you'll be able to work with that. So, yeah,
Yeah, makes sense. Makes sense.
yeah,
Thank you.
yeah. So I think we'll just stop there for today. So we'll probably be having more sessions later. But we'll have a test based on what we've done.